Alright, grade 12s. Here's a special little video on using the sum, difference, and double-angle identities and how I use them for some of the homework questions. So what you'll see here are a sampling of some of the questions that you'll be asked to do for homework. Then you can double check this and just make sure that you understand. Okay. So for instance in A, let me zoom in here a little bit and we can make better use of this. There we go. So you're given cosine of 43 times the cosine of 27 minus sine 43 times sine 27. And the whole idea is to look at your identities, figure out which identity is cos, so cos A, cos B minus sine A, sine B. Rewrite that in that new form, so cosine of A plus B, plug the numbers in, calculate what that is, 43 plus 27 is 70, and bada bing, bada boom, you're done. In E, 8 sine A cos B doesn't look like anything, but you should notice somewhere that 2 sine A cos B does look like something. So if I factor out the 4, or 4 out of the 8, I get 4 times 2 sine of pi over 3 cos pi over 3. I figure out what the identity is there, 2 or sine of 2A, or 2 times theta, and then I calculate. Question 2 says to simplify and give an exact value. So the cosine of 40 times cosine of 20 minus sine 40 sine 20 is equal to the cosine of 40 plus 20, which is a cosine of 60, and then you go ahead and calculate that. In question 4, it says write as a single trig function. So we've got 2 sine of pi over 4 times a cosine of pi over 4. That becomes the sine of 2 times pi over 4, or the sine of pi over 2. That's all they're looking for here. They're not asking you to calculate what the value of that is. Question 5, simplify to a single trig ratio. So sine 2 theta over 2 cos theta. Sine 2 theta, a double angle identity, is equal to 2 sine theta cos theta. Well, if we've got that over 2 cos theta, the 2's cancel, the cosines cancel, and we're left with sine theta, a single trig ratio. In question 7, we simplify 90 minus x, so that with the double angle, or with the sum identities and difference identities, that becomes cosine of 90 times the cosine of x plus sine of 90 times the sine of x. Well, you should know cosine of 90 is 0. Cosine of x is whatever it is. Sine of 90 is 1, and sine of x is whatever it is. So 0 times cosine gives me nothing, and I'm left with sine of x. Now, this one can be a bit challenging sometimes. You're asked to determine the exact value of cosine of 75. So you need to think of which special angles add or subtract to make 75. Special angles that you can find exact values for. Now in this particular example, I screwed it up. So I checked my answers, they're wrong. And what I've done is I've identified what my mistake was. I didn't erase it, but I redid it over here. And that would be an important lesson for you guys too. You're going to make mistakes. Make notes of what your mistakes are. Okay, I made a consistent error in each of these questions here by treating sine and cosine of 45 or pi over 4 as a half or as a 1 instead of as 1 over root 2. I messed up. So I redid the questions. Over here, I showed where my error was. Okay? So sine of 7 pi over 12. That's like 3 pi over 12 plus 4 pi over 12. Now, it could have been 1 pi over 12 plus 6 pi over 12. But 1 pi over 12 doesn't reduce to anything special to me. 3 pi over 12 reduces to pi over 4, a special angle. 4 pi over 12 reduces to pi over 3, another special angle. And that allows me to go ahead and use my sum identity and then calculate what this value is. Now, again, this is wrong. The right answer is over here on the side. And you can find those at the back of the book. Okay. And then finally, an application. So question 9 gives us a formula. We clean the formula out. We use the formula to make some calculations. And then I'm leaving C out here because I want you to figure that out. Okay, that's it.